Hey everybody, welcome back. This is Tom again, and this is the second video in the Building a Neural Network from Scratch series. In the previous video, we looked at our data set, which was all about banknotes. So we had these four features, which were positive and negative floating point numbers. And those four numbers, based on some analysis, give an indication whether a banknote is a real banknote or a forged banknote. So it's a pretty simple data set in that we only have four features and the expected output can only be 0 or 1. Yes, it is, or no, it's not a real banknote. And we're going to build our network for that. So in this lesson, all I want to do is I just want to get the data loaded in, and I want to put it in the correct format so that we can feed it into the network we're going to be building later on. So this file, you can get it off the website, which is in the description, and just put it in a text file, name it whatever you want, and put it in the same folder as the Python file you're going to be using. Now I'm using Sublime. You can use whatever you want in order to do this as long as it works for you. You are going to need to be able to install one library, which is called Numpy. So whether you do that through some sort of library managing tool like in PyCharm, or whether you just use pip install at the prompt or the terminal, either one of those will work. So in this case, I'm going to import this numerical Python library. And if you don't know what this is, really it is a highly optimized library that allows you to do mathematical calculations like matrix multiplication and a whole bunch of other stuff. And it's really fast because underneath the Python part of Numpy is a bunch of C libraries. And C is a compiled programming language which goes, it's much faster than a scripted language like Python. So it uses C, writes all the matrices and arrays in C, and then does the multiplication and then gives it back to you through some sort of middleman, which is made all in Python. Okay, so now that we hopefully have a basic understanding of what Numpy is, let's go ahead and start building stuff. So I'm going to first create my main function. Okay, so in the main function, I'm going to load this file. So the data banknote authentication.txt. All right, and I'm going to read in all the lines from that. Now, what we want to do, and you might know this if you've looked at anything from machine learning before, is we want to take all of our data and we want to split it into two chunks. And the first chunk is going to be called the training set. And the training set is what's going to actually train our network to do, the predicting whether it is a real banknote or not. And the other chunk is going to be our testing set. And what you can think of these kind of like, if you're in 4th or 5th grade and you're learning multiplication or division, and your teacher gives you those worksheets with like a million problems, and you've got to go through them one at a time, and you're just practicing learning the skills of division or multiplication. Then the next day they give you a test on that skill that you learned the previous day, and that test will be similar, but different numbers than you had the day before. So it's similar type of problems, but all of the underlying data is different. All the numbers are different. And that's kind of what the training and testing set is. We train our network to predict whether the banknote is real or not. And then once we're done training, we want to test that network to see whether it's working or not. If it is working, then it should be able to correctly predict whether most of these test sets are or not a real banknote. If it doesn't, if the test set is, giving us 30% or 50% accuracy in this case, then obviously we've done something wrong. All right, so let's go back. We're going to load in all the lines. And what I'm going to do is I'm going to use something in Numpy to shuffle these lines. You might be asking why I want to shuffle them. Well, if I have my list, right now the list is all the zeros come first and all the ones come next. And what I want to be able to do is shuffle it all up so I can just split it, that whole long list of data points, split it in one place and have a mix of of zeros and ones, because I don't want to test it all on, ones. I want to test it on ones and zeros to make sure it can do both. And I don't want to train it all on zeros, because then it will never be able to predict something that is a one. Okay, so I'm going to shuffle it all up, and then I'm going to kind of split it up. But before I can split it up, I need to convert all of inlines. I need to convert all of these into floating point numbers, because when I read this in right now, it's just a big string. So like if I were to, for example, if I take my lines and I print out the first one, this is actually a string. And you can see that if I print out more of them. You're going to see this is actually a string here, and it even has the carriage or turn here at the end. So I want to convert these all to floating point numbers, and I'm going to do that. I'm going to make an input, and I'm going to make an expected output list. This is where I'm going to keep the things that I split up from the lines. So I'm going to say line equals line.split, and I'm going to take that data and split it on the commas. And then I'm going to say input.append. Now that I've split it here, so I'll just give you an example here. If I split this, let me print this out. What I get are all of the data points. Right now they're still strings, so they're all split like that. I need to get rid of the strings, and I need to take these four, I need to put them in the input, which is our input data for the network. And then I take this one and put it in the expected output, which is the answer based on those features. So let's do this, and we're going to append. Now there's more efficient ways to do this, but I want to make it kind of easy to follow here. So I'm going to say line 1. So I just take the first element. In this case, it would be this negative 0.77. I convert it to a floating point, and I'm good to go. And what I'm going to do is I'm going to do that for each of these. Okay, and that takes the first 4 and it attaches it as another list. So this is a 2D list that we're building here. The input list is a 2D list, and the expected output will also be a 2D list. So this is going to be float. I think I already have it. There we go. And there we go. So that, if I were to print out, for example, let's just print out the first one here. So I print out the first that for the input, and I print out first to the expected. I get this. So the first data point, the first sample I have is this list of input features. And then I have the expected output, which is 0. And if I pick just some other random number in here, I'd get another matching pair. So you can test that out by yourself. Now, before I can move on, I want to actually convert this into a NumPy array. So why am I converting to NumPy? Well, NumPy has to have things in its format in order to be able to do all of our matrix multiplication. So I'm gonna put these into Numpy arrays, and this will just convert it for us. And so now if you print out this, if I print out input, what happens is it's actually different. It prints out different. It doesn't print out everything, because NumPy will print out things slightly different. It's nice and formatted for us actually. This is all of the input data, and it puts this little ... here indicating that we're not printing out the full set of data. And if you print out the expected data set, it'll be the same thing. All right, so the last thing we need to do is we need to split it into our training and our testing data. So what I'm going to do is I'm going to say input train, and I'm going to split input train. And in this case, I'm just going to say 1100. 1100 is, I don't know, maybe a little more than 80% of the data set. I think the data set is around 1371. So actually it's probably pretty close. So we're going to do that. and that cuts off. This is just splicing. If you don't know what this is, take a look online under Python under splicing. So I'm going to say the input training, and I'm going to say input test, and I made a mistake here. This should be input. So I'm going to take the big chunk, and that will be my training, and then I just move this over here, and my test set will be everything that's left. So this goes from the very beginning up to 1100, and this goes from 1100 to the end. And what I want to do is also have my expecting test set is also going to be the same. I'll just do that, and there we go. All right, so what I've done is I have put my training and my test set, and I've got them all split up. Now let's just go ahead and put the training sets together and the test sets together. It's a little bit neater. Okay, so we've got the training set and the test set. All right, so that's all I'm going to do in this video. All we really did was just break up our data. Now it seems like we've got a lot of stuff going on here, but hopefully it's not too complex. Just to walk you through really quick, we open the file, we read in the lines, we shuffle those lines up because we want a good mix when we split it of banknotes and fake banknotes. And then we loop through them, and this is just changing things from floating points, from strings into floating points, convert it to a Numpy array, and then we split it into training and test sets. So if you don't follow any of that, ask a question in the comments or in the comment section, or just watch the video again. And the next video, we'll actually start building the network itself. All right, cool. Thanks, and I'll see you in the next video.